Welcome. This channel is going to be about conceptual design. So most of my professional career as a graduate with an aerospace engineering degree has been focused on research and development for various industries. So this included airplanes, spacecraft, engines, and also most recently the power industry. So I'd like to start this with first, what is conceptual design? I'm not really happy with the existing definitions and explanations of what conceptual design actually is, so I'll try to come up with my own definition here. So conceptual design is a process of taking a raw idea and turning it into a consistent and feasible, buildable product. There are all kinds of people that do concepts, they come up with ideas, but they can't actually be made, or they're so expensive to be made that no one's actually ever going to fund them, or it's fundamentally flawed. That's not what this is about. This is about actually coming up with an idea that is going to work. So depending on what you're actually designing and how experienced you are, conceptual design could take anywhere from hours only for something very simple to years for something quite complicated with a lot of different parts. And as I mentioned, for a non-expert, someone who is fresh, it takes more time because there's a big learning curve. The big thing about conceptual design is that big picture thinking is required. So on an airplane, as an example, the flow on it, the structure, the flight control system, all of these interact, and all of these have different effects that when you change one thing, it affects the other. So if you change the airflow around an airplane by changing the shape a little bit, that changes the structure. But that also changes the way the flight control system works. So it's a very integrated process of coming up with a conceptual design of something, because you have to be able to understand every little bit and piece to enough of a level to understand how everything affects each other. That's the hard part. It's relatively easy to go and look up equations and details for certain areas if you're mathematically literate. If you can do some math, you can look up equations for things. But being able to visualize how something is going to affect something completely different, that's the hard part. So that's the gist of the difficulty in conceptual design. But it's big picture thinking. That's always going to be the issue, is thinking big picture, solving the big problem. The reason why I want to focus explicitly on getting something built is it's very easy to come up with an ideal race car or an ideal airplane or something that just I dreamt up and does everything perfect and it's nice and it's exact, everything works. And there's some kind of magical printer that exists. Even though we have 3D printers, there is no magical printer that's just going to come up with the perfect thing every time and print it out exactly the way it should be, with all the little details, with all the different materials, with all these issues solved right away. In this reality, you actually have to figure out how parts go together, how to join them, how to assemble them, how to accurately tolerance the tooling and everything that's required to make these things work. It is not easy, but I want to help. So I want to focus on all of these things to the details so that you can help understand how to design things better. I want to see more things get designed well in the world, and I want to see more things that don't waste a lot of money and time and effort, because life is precious. We only have a little bit of time on the earth. So the more time that we spend on productive projects that will get built, that are useful to other people, the better. That gives us more time to enjoy ourselves, to enjoy our lives for whatever purpose. So that's what this channel is about. Conceptual design, going from a raw idea to something that you actually know will work, and then figuring out how to get it built and into the world. If you have any questions, please leave them in the comments below, and I'll see you next time.